Okay, guys. First of all, I'm sorry it's late in getting this up, but while most of you are enjoying your lovely turkey dinner, I was flat on my back with a cold, so I don't know who gave it to me, but I'm very mad at you. All right, so we're doing the product and sum of roots of a quadratic. So, as you know, this whole chapter is about the quadratic, and for its most part, it's about the roots of a quadratic. And now we're looking at what happens when we add the roots together or multiply the roots together. Now, one or two of you may be going, well, we always do that anyway. All right, let's see if we can catch the rest of you up to that one smart person. There are three ways to find the roots. You can factor, you can complete the square, or you can do the quadratic formula. Most of you prefer factoring, quadratic, and then completing the square. So when I look at this problem down here, well, you can factor that right away. No need to even complete the square of the quadratic formula. Because you look at this and you say, two numbers that multiply to 15, but add up to 8. Oh, I get it, Mrs. Trulin. Tricky, tricky. Sum and product. Get it? Sum and product. Oh, we've been doing this since freshman year. Give me two numbers that multiply to 15. 3 and 5. But at the same time, add up to 8. So the roots of this quadratic are -5 and -3. Ha! So what are we doing with these? Well, we're summing the roots and we're doing the product of the roots. So let's go back. Okay, so the roots were -5, and I'm going to add -3, because this one wants me to add them together, and I get -8. This one says to multiply the roots. So -5 times -3 gets me +15. And if I look at the original problem, I could have gotten those answers without having to factor and actually find the roots. And here's how. The formula for the sum of the roots is -b over a. Just take the b value, which is 8, negate it, and put it over the a value, which is 1. And notice how this is the 8, and that's what you do anyway. Don't you find two things that multiply to 15, but add up to 8? So that's why the sum of the roots is the -b value over a. And product of the roots simply says take the c value, which is 15, put it over the a value, which is 1, and you got your answers. And if you notice one more thing, all you brilliant people, the quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. See the sum of the roots? See the -b over 2a? All the formulas are like each other in this section, so you just have to, in your mind, separate them. All right, this one says find the sum of the roots and the product of the roots. All right, well, I'm going to do the formula way because it's easy. So the sum says take the -b value and put it over a. When I look up here, I see my a value is 1. I see there is no b value here, so it must be 0. And then the 4 is the c value. Okay, so -0 over 1. No such thing as -0, so the sum of the roots is 0. Okay, product is the c value over the a value. So the c value is 4, the a value is 1, so the product is 4. Now, you could have done this the long way. If you can't remember those formulas, as most kids happen when the Regents is, I could have taken this problem and solved it. So I'm going to do completing the square. So I'll take the x's and get them alone. But look how easy this is. I really don't have to go through completing the square because now I can just take the square root of both sides. And x is plus or minus 2i. So if I came back up here, let me change my color, and I took the sum of the roots, 2i plus a negative 2i, gets me 0. Now if I multiply those, 2i times negative 2i gets me negative 4i squared. I remember I squared is a negative 1. See? So this is a section you can either do formula driven or what I call common sense driven. And it actually, in this section, one way is not always easier than the other way. For example, this one. I have to find the equation now. And all they gave me were the roots. I'm going to do it the formula way. So I know the sum of the roots is found by taking the opposite of the b value and putting it over a. Okay, well I do know the sum of the roots because I can take 5 and add negative 2 onto it. So I know the sum of the roots is 3. So the sum is the negative b value over a. I'll put this over 1. So according to this, the a value is 1 and the b value is negative 3. Right? Because if I did negative b equals 3, so b equals negative 3. So that's where I'm getting the negative 3 from. Let me erase all that. Okay, now I'm going to do the product. Well, the product of the roots is the c value over the a value. Okay, so I'm going to come over here, I'm going to take my two roots, I'll multiply them together, and I get negative 10. So that's the product. So the product is the c value over the a value. Once again, the a value is still 1, and the c value is negative 10. All right, so the original quadratic, well, this is easy now, x squared. Okay, the b value is negative 3, negative 3x, and the c value was negative 10. And to make it an equation, I'll set it equal to 0, because this was another thing we argued with the state. On the Regents one year, we had all our kids set it equal to y. It's a quadratic equation whose roots are 5 and negative 2, but the state said no, unless it says equal 0, we had to take a point off. That was the question we had the Stony Brook professors call the state on. And the professors told them that we as math teachers were right and the state was wrong. But everybody lost a point on it. So you have to write equals 0. Now the common sense way is, actually see this formula way over here? That was long. I'm going to do the common sense way. I'm going to go backwards. Well, if the roots were 5 and negative 2, then 5 came from the factor x minus 5 and x plus 2. And if I FOIL that out, wow, I get the same answer. So once again, either formula sense or common sense. In that case, I would have gone common sense. But in this case, I'd probably go formula sense, because the roots are not pretty. They're ugly. So if it was common sense and I worked backwards, this came from x minus 1 minus radical 6 over 3 times x minus 1 plus radical 6 over 3. How would you like to FOIL that out? There's actually a short way, but it just looks ugly. So I'm going to abandon that way, and I'm going to go over to formula sense. Okay, formula says if I take the sum of the roots, it becomes negative b over a. You can probably hear my dog crying in the background. We're in Vermont. She wants to go chase the snowflakes because she's never seen snow before. She's not that bright. Okay, sum. All right, so 1 minus radical 6 over 3 And I have to add on to that 1 plus radical 6 over 3. And look what I get when I add those together. The radical 6's cancel out, so 1/3 plus 1/3 is 2/3. Okay, so that means negative b over a equals 2/3. Okay, product of the roots. So I'm going to have to come over here, and I'm going to have to multiply this together. Okay, she's still growling at the snowflakes. Got to pause it again and let her go out and chase them. Hold on. All right, so if I multiply this together, what happens now is on the bottom I get 9. And on the top, this is a difference of 2 perfect squares, which this chapter's been opening you up to. So I know if I multiply, the middles are going to cancel out because they are negative and positive. So I get 1 minus 6. And I get negative 5/9 equals C over A. Now if you notice here, the A value up top in this one is 3. And the A value here is 9. So what I have to do is make a common denominator. So this fraction is really going to turn into 6/9. So now if I pick out all my A values, and I pick out my B values and my C values, my A value is 9. My B value is negative 6. And my C value is negative 5. So the original quadratic must have been 9x squared minus 6x minus 5, and then again equals 0. Okay, just one more slide. Given one root is 1, and the equation is x squared plus bx plus 3 equals 0, find the other root. Well, I'm going to kind of doing this common sense-wise. If root is 1, that must have come from the factor x minus 1. And I'm trying to find x minus another root, and that gets me x squared plus bx plus 3 equals 0. All right, so if I FOIL this out on the left side here, I get x squared minus ax minus x plus a equals x squared plus bx plus 3. If I combine this all together and start solving, the x squareds cancel out. Over here I have negative ax minus x plus a equals bx plus 3. Now, I know these are going to combine to get that, and look what's left. The a must be 3. Now don't confuse this a with the formula. I just happened to use a variable here. I could have used any variable. So I'm finding out that this is 3. A is 3. So if x minus 1 was one factor and x minus 3 was the other factor, because I just put this 3 in there, so it means my roots are 1 and 3. And that's all they asked me to do, was find the other root. So the other root is 3. Okay, we're done.